So I divided it out by the first divisor, the 0 here. So I started with x to the fourth. I'm going to end up with x cubed plus 3x squared plus 8x plus 24. Now I'm going to use my other 0 that I found from the graph, negative 3. So you have a 1, a 3, an 8, and a 24. Divide by negative 3 this time. It's my other 0. 1 times negative 3. Negative 3 plus positive 3. 0 times negative 3. 0 plus 8. 8 times negative 3 is negative 24 plus 24. 0. Okay, so I'm down to my quadratic x squared. This is my x to the first. I'm going to leave it out. Plus 8. Okay, this is a quadratic. It's not a difference, and it's not certainly not a difference of squares. So what are we going to have to use? That's right, quadratic formula. My a, in fact, here's my a, b, and c. A equals 1, b equals 0, c equals 8. Okay, x equals negative b, which is negative 0, plus or minus square root of b squared, which is 0 squared, minus 4 times a, which is 1, times c, which is 8, all divided by 2 times a. Then I'm going to do my square rooted discriminant off to the side. So I have the square root of 0 squared is 0 minus 4 times 8, 32. This is actually a pretty hard one because 32 is not a perfect square, but it can be reduced to a square root of a perfect square. The largest perfect square that's a factor of 32, 16. 16 times 2. Okay. Square root of 16 is 4. Then my I term goes next. So 4i. And then I'm left with the irrational square root of 2. All of this gets back substituted back into here. Okay, so I have x equals, I'm going to leave this 0 out, plus or minus 4i square root of 2 all over 2 times 1 is 2. Now I could still factor out a 2 here because 2 goes in the 4 twice, 2 goes in the 2 once. So I get plus or minus 2i square root of 2 over 1. So here's my other two zeros. plus or minus 2I square root of 2. Now, since most only a few of you are taking notes, I'm assuming you guys can do all this on the test next week.
I'm still a little confused how you got -3 and 3 in the first place.
Oh, I graphed it.
Oh, okay.
Okay. Remember I put this in there?
No,
I put x to the fourth.
I wasn't looking, I won't lie.
x to the fourth minus x squared minus 72.
Mhm.
Graphed it, and I got the real solutions -3 and 3. I double checked by looking at my table. See my y values 0, 3, and -3.
Okay.
That's how I got the original real zeros. And you say, boy, that was fun. Let's do some more. You know what was really fun? My last class, I had a student solve a different way, factor a different way. So I'm going to do a shortcut here. If you follow your factoring flowchart, what is the first thing that says you can do? You should do.
I don't know.
Instead of putting this all into my calculator and getting 2 zeros, they give us 1 0 already, but I need 2 of them, right, to get this down to a quadratic. I can easily get a second 0 without putting this in the graphing this. Huh? I can factor out an x, right? There's an x term in each one of these. Okay? So if I take out an x, this is x cubed minus 6x squared plus 16x minus 16. And this x, if I set it equal to 0, this x has to equal 0. So I have 2 and 0. Instead of putting all this into you could put it in a calculator and you'll get the 2 zeros, like I did it in the previous problem. But this is another way. And then when I go to synthetically divide, I already used the 0. So I'm just going to take this x. I can only do this synthetically once. Okay. Using this one, I have 1x cubed minus 6x squared plus 16x minus 16. I use the 0 to divide out, so I need to use the 2. And that way, I only have to synthetically divide once instead of twice. Bring down the 1. 1 times 2 is 2 plus a -6, -4 times 2, -8 plus 16 is 8 times 2, 16 plus a -16, 0. See how that doing it this way brought me right down to an x squared, a quadratic, fairly quickly. Okay, now I got to find the other 2 zeros. And if you try to factor this, it's unfactorable. Okay, so we're going to have to use a quadratic formula. And what this student did last hour say, hey, I don't like the quadratic formula. Can you use completing the square? And I said, well, let's try it. Guys, remember completing the square? Because I sure didn't last hour. Subtract the 8 from both sides. So I get x squared minus 4x. Now remember, I'm going to add a perfect square to this. I get negative 8, and I have to add that same perfect square. Then I take negative 4, my b, divided by 2, and square it, which equals negative 2 squared, which equals 4. Add that 4 to both sides. You guys remember this? And then I get my factor here, x minus 2 squared equals negative 8 plus 4, negative 4. Then I square root both sides, and this is where I screwed up at my last class. Square root cancels out the power 2, and I get x minus 2 equals plus or minus. Now, the square root of 4 is square root of negative 4 is square root of 4 times the square root of negative 1, which is 2i. Then I have to add 2 to both sides. So x equals 2 plus or minus 2i. There's my other two zeros. So I have x equals 0, x equals 2, and x equals 2 plus or minus 2i. I thought that was pretty cool. Should I do one more?
Yes.
Oh, that was a resounding yes. Okay, how about let's do number 7. Let's see. I have an x in every term. Should we use a shortcut or should we synthetically divide twice?
A long way.
The long way. Okay. So I only have the 1 0. So I need another 0. So I'm going to use my handy dandy calculator. I'm going to put in x to the 4th plus x cubed minus 7x squared minus 15x. Graph it. Okay. So I can see my 3 on one of the intercepts, and it looks like x equals 0 is going to be another one, right? Let's just double check. Go to our table. And my y value here is 0. My x is 0. Good. Yep. Double check. And it looks like those are my only real solutions. So again, I'm going to have 2 imaginary solutions, right? Which means I'm going to have to use quadratic formula or completing the square. This one will use quadratic formula. Okay, coefficients of the dividend. 1, 1, negative 7, negative 15, and my constant 0. I'll use the easy one first, 0. Bring down the 1. 1 times 0 is 0. 1 plus 0, 1 times 0 is 0. In fact, no matter what I get down here, these are all going to be 0. Negative 7 plus 0, negative 7. Negative 15 plus 0, negative 15, and those is just 0. So I'm down to, let's see, it started with x to the 4th, so this is 1x cubed plus 1x squared minus 7x minus 15. Okay, coefficients 1, 1, minus 7, negative 15. This time I have to use the other one, which is 3, the other 0. See, bring down the 1 times 3. 3, 1 plus 3, 4 times 3, 12 minus 7, 5 times 3, 15, and these add up to 0. So I'm finally down to my quadratic 1x squared plus 4x plus 5. And I know from the graph that it has imaginary solutions, but I know I can't factor this. So I'm going to have to use quadratic formula. See, my A, B, and C are up here. A equal 1. Or you could just read them off of here. B equal 4. C equal 5. So x equals negative b plus or minus square root of b squared minus 4 times a, which is 1, times c, which is 5, all over a 2 times a, which is 1. Bet you guys, when you walked in here, didn't think you'd have this much fun.
I'm having so much fun right now.
I know. Try to contain yourselves, okay?
I'm trying.
Okay, let's go ahead and solve the square root of the discriminant here. Square root of 4 squared is 16 minus 4 times 5, 20, which equals the square root of negative 4, which equals square root of 4 times square root of negative 1, which equals 2i. Going to put this 2i back in here for the discriminant. So I get x equals negative 4 plus or minus 2i all over 2. There's a factor of 2 in every term. 2 goes into 4 twice, goes into 2 once, goes into itself once. So here's my other two zeros. Negative 2 plus or minus 1i or just I. So my zeros. X equal 3, 0, negative 2 plus or minus I. Pretty cool, huh? I know that you're all so excited right now. Try to calm down.
I don't know if I can, but I'm so excited right now.
I know. Deep breaths. Deep breaths. Oh, I can't stop my video. It won't stop. Oh, this could be trouble.
The power. I know.